Hello everyone. So we'll start with October 2023. October 2023 P3 paper. So let's start. So obviously, just like your other questions, this question might have like 10 to 9 questions. We are going to follow this serially, starting from 1 to the last. So from question 1, a curve has equation y is equals to fx, where this is the equation. We need to show that fx is equals to 0 has a root a, where a is the root but it is an unknown term, and you need to identify that that root lies in between this range. So whenever they ask you to find out that a is a root, right? Whenever you're talking about a root, for the final remainder is always 0, right? For a number to be a root of a polynomial, that when you just input that root into the polynomial, the remainder will always be 0. So they have also already stated this also, that for this root a, the remainder was 0. So we need to prove that this root a lies in between the range 1 and 2. So whenever this kind of question arrives, you always use fx, and then you just identify that maybe for plus this 1 and 2, within this 1 and 2 range, one will give you a negative value and one will give you a positive value. So if you look up to a number scale from negative to positive, there will be obviously a state where the number was 0, right? Because on the left hand side it's negative, on the right hand side it's positive, then obviously 0 was in between them. And if the remainder was 0, that means a was obviously in between that 1 and minus 2 range, so 1 and 2 range. So this was the explanation. So we'll start part A. We'll start with the basic fx, right? So we have the equation fx x square minus 5x plus e power x. So for the range that is provided 1 and 2, we're just going to use 1. So x equals to 1. So this is f1 1 square minus 5 1, and then obviously e power 1. So you have 1 square minus 5, then plus exponential power 1. You get minus 1.2817 and a very big value. So we'll just write it to 4 decimal places. Minus 1.2817. Okay. And then again, I'll do another calculation for x equals to 2, which is f2. So if you do this value again, sorry, I actually made a mistake. Okay, now you get a value of 1.3891. Okay, now we can clearly see this is a minus value and this is a plus value. So for your x equals to 1, you got a negative value, x equals to 2, you got a positive value. That means obviously your root a must lie in between this range, because the remainder of 1 and 2 has a change, like a change in sign from negative to positive. That means there was some point where they will get 0, where the remainder would be 0, like confirming that a must lie in between this range. So we need to not explain anything for this part. That's just that is enough for it. Or you can just state that as the sign changes from negative to positive, there must be a point where remainder was 0, stating a must lie in between 1 and 2. Okay, if you want, you can just write the statement also, that's totally fine. Okay, the irritative formula is this one, and they have also provided x equals to 1 is used as an appropriate, like approximate value for the root a, and we need to find the x2 over here. So obviously, if you have x subscript n plus 1, you just can use the x1, and that becomes n1 plus 1 is basically x2, right? So wherever you have xn, you'll just input x1 in that position. So for part B, you have x1 plus 1, which is 5. X1 was just 1, so it's quite easy. Then this e power 1 entire thing under a root. So if you calculate it, 5 minus exponential 1, you get 1.5105. Okay, we are asked to keep your answer to 4 decimal places, so we just keep it till then. So you get x2 1.5105. Okay, now again, by repetitive irritation, the value of a giving you answer in 4 decimal places. By repetitive, they mean that you need to continue this irritative formula for the term until this value gets constant. Okay, so I'll just like for the second, like for the third part, like when I have to calculate x3, I'll just use x2 plus 1, right? And then again for x4, I'll just use x3 plus 1. That's it. So just erase it. So for part, I think it's B2. Right, it is B2. So for x3, I'll just write it like this. I'll write the x3 in very much detail. For the other parts, I will not do this calculation. I'll just use my calculator to find the final values. So for x3, I'm doing x2 plus 1, which is basically 5x2 minus e power x2 to the power of 1. And then again, I'll input the values of x2, which was 1.5105. So you have 1.5105 minus e to the power of 5105, and this entire thing under a root. So again, if you calculate it, you'll get the value of your third term, which is x3, 1.5105 minus exponential, then 1.5105. Okay, so you get 1.7388, 7388. Okay, so now again we'll continue this. I just don't want to move to a new page, so I'll just do the rest of the calculations over here. I'll then find out x4, which is basically x3 plus 1. That means on every spaces where I wrote 1.5105, I'll now just write 1.7388 for this one. So 1.7388, 7388. That is 1.7331. So it is, I'll just not use that much space, 1.7331. Okay, and then again I'll move x5, which is x4 plus 1. Again, instead of writing 7388, I'll write 7331. So you get 1.7342. So again, instead of writing 7331, I'll write 7342. Okay, so now you get 1.733. It's almost 40 because it's 3395, so it's 7.340. So for 6, like this one, it will be 6 plus 1. Then you get the same thing, 1.7340. I know from the next other terms, you'll always get that 1.740. So just for surety or for a little clearance, that I'll calculate one more, which is 7 plus 1, 8, and that will be again 1.7340. So the final value for A then will be 1.7340. So A is 1.7340, right? So this is the value for your part A and B. Moving on to the next part. The function f is defined by this over here, and we need to find ff6. Okay. So for part A, if x is x plus 3 over x minus 4. Now f of x means that we need to input this fx into the fx again. So that will be x plus 3 over x minus 4. This is added with 3, and then again this x plus 3 over x minus 4, and then again with minus 4. So I'll not like do any LCMs over here because that will just make this entire equation more lengthy. I'll just input the value for x into every stated value position for x, which is ff6. I'll just use 6 instead of writing x at every point. So we have 6 plus 3 over 6 minus 4, then plus 3, then again 6 plus 3 over 6 minus 4, then again minus 4. So doing the calculations each line at a step, 6 plus 3 over 6 minus 4, this is added with 3. I'm doing the numerator, and you get 7.5 in the numerator actually. And on the denominator, again, if you do the same thing, but just, like have to just subtract 4 from that fraction now, because the fraction is same, then you get half on the new denominator. So 7.5 over 0.5, you get your final answer to be 15. So FF6 is 15. Moving on to part B, where they want to find out the inverse function. So again, for inverse function, I always ask that make y the subject of the equation. It's just easier that way. So if your equation of fx was x plus 3 over x minus 4, we can just start with that let fx be y. So in that case, you have the equation as y is equals to x plus 3 over x minus 4. Okay, so I'll just, by each step, I'll try to take x to the right hand side of the equation so that, sorry, to the left hand side of the equation so that I can make x the subject of this new equation. So you have xy minus 4y is equals to x plus 3. Then again, taking all the x's to your left hand side, xy minus x is equals to 4y plus 3. So you have taken x as a common, y minus 1 is equals to 4y plus 3. And eventually, if you just take x as the subject, you get 4y plus 3 over y minus 1. Right, this is the final stage. After this stage, you do not need to anything, like you do not need to do anything. You can just write this equation in terms of x, because in your question they were asking you to find out the inverse of function in terms of x. Right, it was f inverse x, not f inverse y. So for the last step, you just include this f inverse x is actually 4x plus 3 over x minus 1, and that is the value of your inverse, 4x plus 3x minus 1. So that was it for part B. We'll move on to part C, where the function g is defined by x squared plus 5. They want you to find the value of a, for which they have given you an equation. GFA is equals to 7. For GF, we can clearly understand we have to do composite functions over here again. So we'll start. It's x squared plus 5. GFA, that means that you're actually going to input the equation of f into your equation for g, right? That's why it starts with GFA. So x plus 3x minus 4. Okay. So we'll start with gx, which is x squared plus 5. And then again, we'll start with gfx, which is basically x plus 3, x minus 4. This will be entirely under a square plus 5. And then again, the value for x was a instead of x, right? Because they were asking you about GFA, not GFX. So GFA is a plus 3, a minus 4, square plus 5. This equation was actually equivalent to 7. So you can just write 7 equals to this expression. No need to write it in a separate line. So we have a plus 3, a minus 4 under a square. Just shift that 5 to the right hand side. So you have 5 minus 7 minus 5, that is 2. And then you take this square to the right hand side, which becomes a root over there, right? So you have 7 minus 5 as 2, a plus 3, a minus 4, and equals to root 2. Now in this part, actually, for root, obviously this will be a plus and minus value, right? So you get plus and minus. If I'm not sure, maybe this is not, yeah, they are asking about the exact value, so yeah, this could be the possible answers. So if you just take this denominator to the right hand side, becomes a plus 3. This will actually lead up to your two equations that, wait, no, the value for x is a real number, or they're taking the value for x to be positive over here, I can see. So we'll also take the positive part, not the negative part. So in that case, it's quite fixed. It's going to be a minus 4, which is a plus 3 root 2a minus 4 root 2. And then again, if you take all the a to the same side, becomes a to root a, and then again minus 4 root 2 minus 3. And finally, if you take a common, it's become 1 minus root 2, 4 root 2 minus root 3. Finally, a is Yeah, this is the final answer then, right? We can obviously accept it like this way, or we could have also done one thing is that we could have just broken this square and make it look like a quadratic equation, and then use the formula method to calculate the value for your a. So that would also do, but we just didn't actually took that process because I think that was quite lengthy. So we'll just accept this one. Right, we're also accepting all the positive value over here only, not the negative value, because they gave the answer that x was greater than 0, right? Okay, so yeah, that is it for question part C. I hope it was clear. This was the end for your question 2. Moving to question 3. Okay, now they have stated over here that cos 2a is equivalent to 2 cos square a minus 1. We have to like derive this format using this equation. So now in this part we cannot see any a, right? That means both the angles are considered as a. That means we have to first state that a is equals to b is equals to a. Like both the angles will be equal to a. So we can just write for part a cos a plus b. We have to assume that a is equals to b is equals to a, right? That both a and b are going to be considered as a. So we can write cos a plus b, that will be broken down into cos a, cos b. So again cos a because both angles are a. Sorry, then there has to be a change. This is going to be sin a, sin a. Now obviously a plus a gives you cos 2a, so it's cos 2a, cos a, anything similar multiplied twice it becomes a square. So you have cos square a, and then over here you get sine square a, but instead of writing sine square a, we are just going to use the equation sine square a is equals to 1 minus cos square a. Right, so instead of writing this, I'll directly input 1 minus, wait, sorry, for positive cos, this has to be the negative part. So again, if I input 1 minus cos square a with a negative sign, this will entirely look like minus 1 plus cos square a. So the 2 cos square gets added together. You get 2 cos square a minus 1, and this is cos 2a. So this is the format that we're supposed to keep your answer in. Lastly, moving on to this, we need to integrate this one, find the exact value of this. Okay, now you have cos 3x, right? Okay, so for that part we'll just do some derivation at the very first from this equation from part a. We have cos square a, and now they want cos square 3a, right? So from this part cos square a minus 1 is equals to cos 2a, right? As you can see, if you had 1a over here, it gets 2. So instead, if you had like 3a's, it will get 6, right? Because it's just the format that whatever the value of angle was over here, it will get twice on the right hand side. So if you have like 3x, it will be 3 into 2, 6x over here. So that's why if your equation was maybe cos square 3a minus 1, that will be equivalent to cos, it got 2 because we had 1 over here, right? Now 1 into 2 will just end up being 2 over here, but as you had 3 on this side, so over there you get 2 into 3 is 6a. So we can just write cos square 3a is going to be equivalent to cos 6a plus 1 over 2. Right, this is how your answer for cos square 3a should look like. So because we simply cannot integrate it, right? So your equation was 5 minus 4 cos square 3x with a boundary of pi by 8 and pi by 12. That means certainly you have to do this calculation in radians mode. So we'll start with the integration. 5 minus 4 cos square 3x, I think it was x, with a boundary of pi by 8 and pi by 12. Okay, so if you first break down this cos square 3x, so you have 5 minus 4 cos 6a plus 1 over 2, which is basically indicating this will get cancelled with each other. So you have 5 minus 2 cos 6a plus 2. 5 5, it will actually get minus 2, right? Because it was negative in the front outside the bracket. So 5 minus 2 is 3 minus 2 cos 6a. Obviously, we did not do any integration till now, so we'll write that integration sign in front. Pi by 8, pi by 12, and then again pi by 12. Okay, so then we'll move on to the integration process. So if you integrate 3, it becomes 3x, and if you integrate this 2 cos 6x, it actually becomes like, if you integrate cos, it becomes sine, but it has 6, so it will be like divided by 3 divided by 6, but as it has 2, they will get multiplied with each other, and eventually you get sine 6x by 3. So we first write down the integration. That's 3x minus 2 sine 6x over 6, right? But obviously they will get cancelled out, and you're left out with 3 in the denominator. So with this was the integration done, and we'll just write down the boundaries over here. Pi by 8, pi by 12. So it will look like, now we'll input the boundaries. Pi by 8 minus sine 6 pi by 8 over 3, and then again it will be 3 pi by 12 minus sine 6 pi by 12 over 3. Okay, so that is it. You just need to do the calculation then, and then that will give you the final answer. So if you calculate this, the final answer that you get is pi by 8 minus 2 minus root 2 over 6. Sorry, this is plus actually. Okay. So yeah, this is it, the calculative part of your question 3b. I hope it was clear. We'll move on to question 4. So a new mobile phone is released for sale. The total sales N of this phone is thousands and is modeled by the equation this. Okay, now this was in terms of thousands, right? That means what this actually indicates is that all this equation is in terms of thousands, right? 125 means 12500, right? 125 actually indicates it's actually in the form of 125, ones, tens, hundred, thousand, and thousand, right? In this format, right? It's kind of like 12.5 thousand indicating. So this is entirely in terms of thousand. That's why this thousands is written in bold, because everything in this part is written in terms of thousands. Now they have given you informations as where A is a constant and T is the time in months after the phone was released for the sale. Given that when T is equals to 0, the N was 32, total sales was 32,000, right? This obviously indicates 1,000. So state the value of A. We can certainly do that. We have 125 minus A, e to the power of 0.109t. Okay, so we'll just start with A. I'll just input the values. T was 0 and N was 32. So you get N is equals to 125 minus A, sorry, it was E minus 0.109t. And we can certainly write 32 is equals to 125 minus A, E, minus 0.109, it will be multiplied with 0, right? This entire e becomes actually e power 1. So if you just make a the subject, this will actually look like this, that 32 minus 125 over minus e power 1, sorry, e power 0, right? So this entire thing actually becomes e power 0, because this 0.109 got multiplied with 0, and anything multiplied to 0 eventually becomes 0 itself. So this is the final format. So you get 93 over here. So the value for A is then 93. I'll just erase this. This is not quite needed into your maths. So yeah, this is it, the value for your A. We'll move on to part B then. When the time is capital T, the total sales for the phone was 100,000. Find according to the model the value of T, giving your answer to 2 decimal places. Okay, so according to the model, the value of T, right? The value of capital T, and they have given you the value for n, right? But the value for, like, this is not exactly in the, like, n is equals to 100,000. They are just talking about that the total sales of the phone was 100,000, but as the question was exactly in terms of thousands, then the value of n from this part will actually be 100 only, right? Because n only represents everything in terms of thousands, right? So the 3 zeros will be cancelled out. If you have to use this value into your equation, you have to cancel out those last 3 zeros. So for part B again, we'll use the same equation, but we need to find out the time. So it will be like 100 is equals to 125. The value for is already known to you, 93. E to the power of minus 0.109 with capital T, right? So again, if you have to make capital T, or I'll just write it like this. That will be 100 minus 125, everything under 93. And then if you just take this exponential to the right hand side, you get ln 100 minus 125 divided by, minus 93. And this entire thing will be divided by that power, which was 0.109. It 100 minus 125. Oh, sorry, I forgot to input that minus in here. Right, then you get its time is 12.0525. We should keep your answer in 2 decimal places. So it's 12.05 months, right? Because T was in months. For part C again, find according to the model the rate of increase in total sales when T is equals to 7, giving your answer to 3 significant figures. Remember that over here they're not asking you about the total sales. They're talking about rate of increase in cell. That means they want you to find out dn over dt. You have to differentiate the equation, then input the value of t equals to 7 into that differentiated equation, and then find the value of your dn by dt. Okay, so your original equation was 125 minus 93 e power 0.109t, right? Okay. So for part C, I'll just write down the equation 125 minus 93 e power 0.109t. If you do the differentiation, this 125 will certainly cancel out, right? This power will eventually come in front with the in front of that node 93. So you have 0.10, sorry, minus already in front of 93. That will be multiplied with again minus 0.109 with 93 e power minus 0.109t. If you calculate this, this becomes 10.137, 0.109 with 93. Yeah, this becomes 10.137 multiplied with 0.109, again multiplied with 7, right? Because the value was 7. So I'll just write, so you get 4.7265. Now this was also in terms of thousands, right? So we can obviously write it like this, or it's better to convert this in terms of thousands, which is like multiplied with 1000. So you get 4730, because the question asks you to keep your answer in 3 significant figures. So that's why we're not writing 4726, so 27. We'll just write 4730. Okay. Then again for part D, if we move, they're saying that the total sales of the mobile is expected to reach 150,000. That is basically 150, like 150,000 according to your equation, it will be 150, right? Because we're going to cancel these last 3 zeros. Okay, so from this 150,000, as we can understand, these 3 zeros will be cancelled out. So this is the value for your n, right? They're saying that the model that you have used is actually like that this total sales of this mobile phone is actually expecting that the maximum sales will be like 150. So according to the model, it's going to 150. So we need to use this information and state that why this equation is not suitable for modeling the total sales of this phone, like for this number of. Because if you go back to your equation, right, for the total number of cells, we are actually going to consider that the time is infinite for that, right? Because we're not sure that how much it will take for that amount of sales to be done, right? So for part D, if the equation was dn by, sorry, the normal equation was n equals to 125 minus 93 e to the power of 0109 capital T, right? Where T limits to infinity, this entire expression of 93 e power of 0.109 T becomes 0, right? That means for the infinite time, the maximum value that n can hold is 125, right? This is the maximum value. And what was the expected value from your equation? It was 150. So the maximum value was 150. The maximum value is 125, and the expected value they provided was 150, which will certainly not fit into this equation, right? So you can just write the limit is 125 or 125,000, where and the model and the like, and 150 is actually outside the limit, right? So we can write the limit is 125,000, which is below 150,000. Okay. So yeah, this is it for question 4. We'll move on to question 5. So this is the equation. We need to express this equation in terms of this, like just differentiate it. Okay. So before we differentiate, we can clearly understand this will be a quotient rule differentiation, right? And again, the U differentiation for U will be extremely unique for the other cases, because we have ln x square plus k, right? So if you differentiate it, it becomes, which basically indicates that this is like in a fraction format. So if you differentiate it, it becomes 1 over x square plus k. And then again, you have to, like, subtract, like differentiate everything inside the bracket, which is x square plus k. If you differentiate that, then it becomes 2x, k will become 0 because that's a constant. So finally you get 2x over x square plus k. So this was the differentiation for your part numerator, which will be considered as u. Okay, so I'll just use this. Okay, so for this one, it's 2x over x squared plus 1. And yeah, okay. So this is actually the value for your u, and this is actually the value for your du by dx. Du by dx, right? And then again, we'll move on to v, which was x squared plus k, and dv over dx is actually 2x, right? Okay, so we'll calculate this. Dy over dx is u dv by dx minus v du by dx over v square. So finally you get the value for your u is ln x square plus k, and the value for dv by dx is 2x, minus v is x square plus k, and du by dx is 2x x square plus k. And then finally on the numerator you have x square plus k whole square. Okay, so if you break this down, like, you have to simplify this again. So you have 2x ln, sorry, x square plus k, and then again on the other side, since x square plus k gets cancelled out, so you just have 2x over here, right? And then again, wait, sorry, I actually made a mistake. That this is the format actually. So in that case, this will be positive, this will be negative. So I'll just rearrange it. This will be over here, and this is the state. Okay. So for numerator, its denominator is going to be same. On the numerator, you can take 2x as a common. So you can, the equation can look like 1 minus ln x square plus k inside a second bracket divided by x square plus k under a square, right? Whole square. Okay. So this is it actually in the format, the maximum way we can organize it. If I go back to equation, yeah, that was it in the question also, right? This was the value of 2 and this was the value of 1. So yeah, that is it. So you can just write capital A is equivalent to 2 into equation and capital B is equivalent to 1 into equation. So this is it for question part A, the differentiation part. For part B, they have stated that C has exactly 3 turning points. That means dy by dx is equals to 0 for 3 turning points. And we need to find the x coordinate of these 3 turning points. And we can give our answer in terms of k where they are appropriate. Okay. So for part B, we consider that for turning points, dy by dx is always 0. So the fraction that we got, it was 2x 1 minus ln, I think it was x square plus k divided by x square plus k whole square is equals to 0. So if you just take that denominator to the right hand side, that will also become 0. So you have 2x 1 minus ln x square plus k equals to 0. And again, if you take that 2x to the right hand side, it gets divided with 0 and eventually end up to be 0. So you finally have 1 minus ln x square plus k is equals to 0, which is basically ln x square plus k. Or actually, you should not write it like this. If you just take this 2 to the right hand side, then it becomes 0. So you have like this, x equals to 0 and this, right? Which means that I'll just obviously use this. X is 1, that is equals to 0. And then again, you have 1 minus ln this equals to 0. So from this part again, you'll get two values. Ln x square plus k equals to 1, which is x square plus k is e to the power of 1, which is x square equals to e to the power of 1 minus k, and then x equals to e to the power of 1 minus k with a plus and minus sign, which indicates that we have two roots from here, two values of x from this part. So the final values of x coordinates of the turning point were 0, e1 minus k under positive root, and then again minus e1 minus k under negative root, right? So these are the values of your three coordinates of your x coordinate, x point, turning points. Yeah, so that is it for part B. We will move on to part C. We need to find out the upper limit to find the value of k. Okay. So as this was not related in terms of k, so we'll not use 0, but the other two values were kind of related to 0. So we can write for part C, we can write e1 minus k with a root equals to 0. If you take that root to the right hand side, it just becomes 0 square, which is still 0. So e1 minus k is 0. So you finally end up to get the value of your e1 like k as e1, right? K is equals to e1. So to find the upper limit, right, that will be what, like greater than e1, right? For upper limit, we should have stated with any value. For example, for upper bound, lower bound, we should have been provided with like correct 2 decimal places or 3 decimal places. Then we could find out that what is the amount that should be added to this e1, right, or added or subtracted in order to find the upper bound or lower bound. But as nothing was given for upper limit, we understand that it will be certainly greater than the value that we have calculated, right? E power 1, that should be greater than that. So for upper limit, you can just write for upper limit, we'll write k is greater than e power 1. If it was lower limit, then we would write less than e power 1, right? So yeah, that's it. That is the end for your question 5. I hope it was clear enough. We'll move on to question 6. So an area of sea floor is being monitored. The area of seafloor is S kilometers square covered by coral reefs in model coral reefs is modeled by the equation where P and Q are constants and T is the number of years after monitoring has begun. We have provided with an equation and find according to the model the area of the seafloor covered by coral reefs when time is equals to 3. So you just have to input the value of 2 time equals to 2 into this equation. So we have A log base 10, S is not given to you, with 4.5 minus 0.006 t. So if you just take this s to the right hand side, it will be like s equals to 10 and everything on the right hand side will then become a power of this base. So it's 4.5 minus 0.006 with 2. If you calculate it, you get 376 something. So you can just write like, since you were asked to calculate this in terms of like what? Oh, no, you can just, like decide to keep your answer in detail format, but or you can also like keep your answer in wait, right? That is 30760. We can also write it like this, or you can just write 30800. Right, nothing about the significant figures was provided, so I'll just write 30760 kilometers square. Okay, and then again we need to complete the equation for the model in the form of this so that P and Q are found out, and P or Q has to be like in 3 significant figures, where just basically they indicate you transfer this equation and look it like this, and then we'll find out the numerical values of P and Q. So for that we are already quite close to this. S is equals to 10 to the power of 4.5 minus 0.006 t, right? For minus we can write 10 to the power of 4.5 multiplied with 10 to the power of minus 0.006 with t. So if you just calculate 10 to the power of 4.5, you get 31622, but as your answers were kept in 3 significant figures, that is going to be like 31600. So you get 31600. Okay, then again for 10 to the power of negative 0. Okay, and then for the value for 10 to the power of negative 0.006, you get 0.986. So you get 0.006, which is 0.986. So you get 0.986 to the power of t, right? So that is it. The value of p in that case is 31600 and the q is 0.986. And later on for part C, they want you to find that with reference to the model, interpret the value of the constant q. Like they want you that what does this value of q indicate? So if you just transfer this into the equation of y equals to mx, like this is kind of in the form of y is equals to mx plus c, right? Where p is actually a constant and y is your area of that sea floor, right? Where q is actually indicating that how much of the area of your sea floor will be covered by coral reefs from time to time, from 1 year to 10 year, like from year to year, right? So q represents the area of your sea floor covered by coral reefs from year to year. So you just have to explain that over here, that Q indicates area covered with coral reefs, area covered with coral reefs retained from time to time. So yeah, from time to time or from year to year, you can just write both are fine. So yeah, this is it for question 6. So we'll move on to question 7. Okay. So for question 7, the first thing they want you to is find the range. For range, we can clearly understand the range will never go back to like in the negative axis. The minimum is going to be 0 because the graph never touches the negative y-axis. And the maximum is this one. right, when the graph crosses the y-axis. So it's quite easy. At y-axis x is 0, you already got the lower portion of your range, that your y must be greater than equals to 0, and also equals to 0 because it got equal to 0 in these 2 points. So your y must be greater than equals to 0, and what would be the maximum point we can find out using the value of x equals to 0, inputting into this equation. So for part A, we can write f0, that is e minus 0 square 2 with 0 square minus 3 with a square. Okay, so you get exponential minus 0 square with 2 0 square minus 3 square. Finally, you get 9 over here. So the range in that case would be 0 less than equals to, y less than equals to 9. Okay, so that is it. So we'll move on to part B. We need to show that f prime x can be written in this format where a and b are obviously has to be found. So let's start. This is obviously going to be a product rule, right? Because e minus x square is multiplied with 2x square minus 3 whole square. So so we'll first start with that u part over here. U is e power minus x square, du by dx is minus 2x e power minus x square, right? And then again, you have part v, which is 2x square minus 3x square. So dv by dx is 2x square minus 3, 1. And then it's going to be 4x inside the brackets. So you have like 8x 2x square minus 3. Power 1 should not be written over here. So we'll just continue with dy by dx. That's going to be it's product rule. So u dv by dx minus v du by dx. Eventually you get, for u, you get e power minus x square. And then for dv by dx, you get, for you to get 8x minus 3 with minus sign. V is 2x square minus 3 whole square. And then du by dx is going to be minus 2x e power minus x square. Okay, so for this part again, you end up with 8x e power minus x square, 2x square minus 3. And then over here again, you get plus 2x e power minus x square, and then again 2x square minus 3 square. So what you're supposed to do is that you can take common from this part. If you just focus, you have like what, ex square, you have like x, and then 4 and like 2 and 8 can also be taken into common. So like they have common factors. So you can take 2x e power minus x square, and then you'll be left out with 4 2x square minus 3. Wait, we can also take, like, since you have like 2x square minus 3 whole square, and then over here single, so you can just take that also as a common. So basically over here also you'll get 2x square minus 3, and then again inside the bracket you'll have like 4 over here from this first term, and after that you're just going to have I think we have a plus over here in the equations, right? So it's going to be a minus. It's going to be a minus in this part. So you have minus 2x square minus 3. Right, now just simplify it. You get 2xe minus x square, 2x square minus 3. And then again, if you just remove the brackets, you have 4 2x square plus 3, which is basically 7 plus 2x square, right? So Yeah, 7 plus 2x squared. So I'll just write it down directly over here. Sorry, yeah, 7 plus 2x squared. So it's 7 minus 2x squared in this part. So this was the final answer you're supposed to keep your answer in. So in that case, if you go back to your question, right? So A in that case will be like 7 and B will be minus 2. So you can just write A is 7 and B is minus 2. If it's quite confusing to understand from this stage, I'll just, like take this part to the very top. So just, you can just like see the similarities, right? As you can see that 2x e power minus 2x square, 2x square minus 3, and then a minus bx square is all in the form. So obviously in that case, a is 7, b is minus 2. Right, so this is the final answer. Also, in the stated part, actually, I saw that they kind of wrote this ex square in the middle of these two brackets. So obviously, to keep your answer exactly in that form, you have to rearrange it like this. And yeah, after that, it's quite correct. So yeah, this is it for question 7b. I hope it was clear. Moving on to question 7c. Now they have stated that given that the line y is equals to k is a constant where k is certainly greater than 0 and intersects the graph at exactly two distinct points, we need to find the range of values of k. Okay, so obviously y is equals to k, we can understand it's going to be a horizontal line passing through the y-axis. Right now, in order to like meet the curve twice, right? If this is the line y is equals to k, if it is exactly at this maximum point, in that case the line would be just touching the graph at one point, which does not create two exact point, right? So it must be like less than this point. This was 9, we already know, so it must be less than 9. Y must be less than 9. Y must be situated less than 9 on this curve. And also over here we can see these are the maximum points. If the line is situated below this, in that case you are supposed to get like 1 2 3 4 5 6 distinct values. So obviously that is not the case. So your y, like the line of k, should be also greater than these two maximum points. It should be like above these two maximum points or below this 9. So we already know it should be below this y equals to 9 line. We need to find out these values. So in order to find out these values, we can just use that differentiated equation and find out that. So also remember that you have this maximum and minimum values over here also, right? So the differentiated values will actually give you the maximum and minimum values. Part C, we need to write f prime is equals to 0, which is basically 2x e power minus x square, 2x square minus 3, and then again 7 minus x square is equals to 3, which is basically 2x e power minus x square is equals to 0. For this case, everything will actually end up to be 0. And or does it? Wait. Yeah, exponential power 0 is, wait, yeah, it's going to be end up as 0. So for the next two other points, when you have to calculate that, it's going to be 2x square minus 3, it's 0. Then x is basically 3 over 2 and under a root, which is basically plus and minus, right? That's why the graph had like plus and minus points. So it's going to be plus 3 over 2 root, plus minus 3 over 2 root. And then again we have 7 minus it was 2x square. So 2x square equals to 0, which is again x equals to 7 over 2 plus minus, right? So obviously that is also like plus minus giving you the two values. So in order to find out that range, right, if I go back to this 7 over 2 and for 3 over 2, we can understand that this must be your 3 over 2, right? Because it's closer to the x-axis. This must be the 3 over 2 with a minus value. We're certainly not concerned about this. We're concerned about this one, 7 over 2 root. We're concerned about this one. So in order to find this, you just input this 7 over root into the equation. That is fx, not x, we'll write 7 over 2 root. We're just inputting the positive value because the line actually is a horizontal line, right? We'll pass from the both positive and negative. So we'll have equation as minus x square 2x square minus 3 whole square. So for x square, the value was just 7/2, right? It was not root. So we'll just write e minus 7/2 is just 3.5. So again, it's going to be 2 multiplied with 3.5 minus 3 under a square. So you have this. So you get 0.483 15 something. So what you can do is that 3.5 minus 3 is actually 4, and if you square it, it becomes 16, right? So you can write that this is actually like 16 e power minus 3.5. So in that case, you also found out that, lower range. So for range, you can write range, that is going to be, your value for k should always be less than 9, right? Not exactly equal to 9, it should be less than 9, because if it is also equal to 9, then also the graph will be cutting at one point. So again, it again should be like greater than this lower part, because if it is also greater, like equal to this part, then also the graph will be like cutting the graph at 1 2 3 4 points, right? So that is also not needed. So just write minus 3.5. Right, so this is the final answer for question 7c. I hope it was clear enough for everyone to understand. We'll move on to question 8 quickly. Okay, so for question 8, we need to prove this, that 2 cosec squared 2 theta, 1 minus cos 2 theta can be written as 1 plus tan squared theta. Okay, so obviously we understand that cosec is basically 1 over sine, right? So you have 2 cosec square 2 theta and 1 minus cos 2 theta. So we'll certainly break down that 2 over sine square 2 theta, 1 minus cos 2 theta. And again, we'll break down this and we'll multiply this with the fractions. So wait, even if we multiply it, we get this and cos 2 theta and sine 2 theta, right? Sine square 2 theta. Okay, so we'll just multiply it and then. So we get 2 minus 2 cos 2 theta over sine square 2 theta. For example, for sine 2 theta, you get sine theta cos theta, right? 2 sine theta cos theta. If it is like a square, then you're supposed to get 4 sine theta cos theta. Just wait. Okay. So we can write 2 minus 2 cos. Again, cos 2 theta can also be broken down into 1 minus 2 sine squared theta, right? So you can write that 1 minus sine squared theta. Finally, at the denominator, we can write 4 sine, since we have a square, so it's going to be sine squared theta cos squared theta. So finally, again, we can break this down. It's 2 minus 2, minus minus, it becomes plus 2 sine squared theta over, we have 4 sine squared theta cos squared theta. Right, this is it. So what exactly you get is that this 2 gets cancelled out, right? 2 minus 2 is eventually 0. So you have 2 sine squared theta over 4 sine squared theta cos theta. So if your equation was like what, 1 plus tan squared theta, right? Okay, 1 plus tan squared theta. Sorry, I made a little mistake. It's supposed to be over here, it's going to be 2 sine squared theta. In that case, you end up with 4 over here, right? 2 into 2, you end up with 4. 2 minus 1 is 2, and then 2 into 2 is 4 sine squared theta. Right, so over here again, you end up with 4 sine squared theta. So we can clearly understand that this sec sine square will get cancelled out, and you are just finally left out with what? 1 over cos squared theta, which is basically sec squared theta, and sec squared theta is certainly equal to 1 plus tan squared theta, right? So this is how you're supposed to do your derivation for part A, 8 part A. So For your part B again, they have the same equation, but that is equivalent to 4 plus 3 sec theta, and you're supposed to find your answer in terms of like degrees from in between 0 to 360 and give your answer in 1 decimal places. Okay, so for part B, you have the equation as 2 cos x squared 2x 1 minus cos 2x 4 plus 3 sec x. Okay, so 2 cos sec squared 2x, it was maybe 1 minus cos 2x, it was sec x over here, 4 plus 3 sec x. And then again, we can write for cos x squared 2x, instead of writing that, we can certainly write sec x, right? Sec square x. So we can write sec square x is equals to 4 plus 3 sec x. Then you can just rearrange it and it will look like sec square x minus 3 sec x minus 4 equals to 0, which is basically if you just let that sec x to be like, x or y over here, the equation will be like y square minus 3y minus 4 equals to 0. And finally, you can just split it and do factorization. So it's going to be 4 square, 4y, y, 4, 0. So just take y as common, y minus 4 plus 1 as common, y minus 4, 0, which is y plus 1 and y minus 1 equals to 0. So y plus 4 and y minus 1 equals to 0. And finally, you get y is equals to minus 1 and y is equals to positive 4, which is basically y was your value for sec theta. Right, we considered sec theta to be y. So in that case, we can write sec theta is equals to 1, where obviously, sec theta is again 1 by cos. So you get 1 over cos x equals to minus 1, and then again 1 over cos x equals to 4, which is basically, if you just change the position, it gets cos x to be minus 1, which is certainly not, sorry, this is equal. So x is going to be like minus 1. So cos square minus 1. This is supposed to be in degrees, so change your angles. So cos square minus 1 is 180 degrees. So the second value over here is going to be like what? 360 minus 180. That's again going to be 360, 180, right? 360. Yeah, that's going to be 180 again. So we just accept 180 over here. Wait, maybe I'm making some mistake or something. Cos inverse minus 1. They have stated that where x is not equals to 90 and like your value of x will not be a like a factor of 90n. 180 is exactly a factor of 90n. So that's why we're not considering the value of this one, because the question stated that this will be not equal, right? So that's why we're not accepting this value of 180 degrees. So we'll quickly move on to cos x equals to 1 by 4, where x is basically cos inverse 1 by 4. So you get cos inverse 0.25, which is 75.5. And the second value would be 360. That is 284.5. So these are the values for your x. So this is the final answer for your angle. And 8b also. I hope it was clear. We'll move on to question 9. Okay, so for question 9, they have provided you with a graph, and they have stated that figure 2 shows a sketch of the curve with equation this one, and where k is a constant, given that the curve has an asymptote at x equals to k, as you can see, and meets the x-axis at point A, sorry, y-axis at point A, and meets the x-axis at point B. We need to state the value of k. Okay, for the value of k, we are going to use this in the insides of the equation, right? That x plus k should be equals to 0, and that will certainly give you the value as minus 1. So we can just write the solution for part A over here exactly. X plus 1 is equals to 0. In that case, x equals to minus 1. Therefore, we know k is equals to minus 1. Okay, and then for the y coordinate, we know for y coordinate x is 0. So for part B1 also can be calculated over here. If 0, that's 2 minus 4 ln 0 plus 1 is 0, is 1, right? And under a modulus. So you have 2 minus 4 ln 1, and that is equals to 2. So point A, the y coordinate of point A is 2. For part B, they want you to find the x coordinate of point B, where the y coordinate is 0. So you can write 2 minus 4 ln x plus 1 equals to 0. If you take this 2 to the right hand side, it becomes what? 2, right? But everything will be positive because it was a modulus. So you actually end up with like this: ln x plus 1. This is going to be 2 over 4, which is basically half eventually. So you can just write 0.5, and the value for x is going to be like what? E to the power of half minus 1. So that is your x coordinate, e to the power of half minus 1. So this was a solution for your part A and B1, B2. So just write it down in this part. Okay. And then again, for the last part, they stated that using algebra and showing a working for the set of values of x for which this graph is greater than 3. So in order to find that, first we need to draw a line. Wait, wait. Okay, I am assuming that this is like y is equals to 3, right? So we have to find first the solutions in between the graph and the line intersects. So for that, we can write it has to be one in positive and one in negative. So you have like for part C, 2 minus 4 ln x plus 1 with the modulus is equals to 3. I'll not first focus on the inequalities. With a plus over here, that is going to be 2 minus 4 ln x plus 1 is equals to 3. So if you just take that 4 to the right hand side, it becomes 2 minus 3 is minus 1, right? So basically 4 ln x plus 1, that is going to be minus 1, and ln x plus 1 minus 1 by 4, which is basically e to the power of minus 1 by 4 minus 1. Okay, this is one of the coordinates that you're supposed to get. And then the other one would be for the plus, for the minus 1, that is going to be minus 2 plus 4 ln x plus 1 equals to 3. So then again 4 ln x plus 1 is going to be positive 1, and we can understand from this part it's going to be like 1 over 4 minus 1. Or is it? So wait, sorry, it's going to be 3 plus 2 is going to be 5. So that's going to be 5 by 4. 5 by 4 minus 1, right? So in that case, if you go back to your graph again, this is maybe e to the power of 5 by 4 minus 1, and this is maybe e to the power of half minus 1, or 0.25 minus 1. So in that case, your graph was maybe supposed to be like what? Greater than this, right? If your graph is greater than the line, then the inequality should be greater than this upper bound, lower than this upper bound, right? So we can write x should be greater than this e 5 by 4 minus 1, or x should be less than this minus 1 by 4 minus 1, right? So this is your values for part C. I hope question 9 was also clear. Moving on to question 10. Okay, so for question 10, they said that a curve C has equation x equals to 4x square for sine square 4y, and they have also provided you with the values that when at point P the x coordinate is 1 by 4 that lies on C, find the y coordinate of P. That means clearly that they just input the value of this 1 by 4 into this equation and then just make y the subject. So it's going to be 1 by 4 sine square 4y, which is basically 4y is sine inverse 1 over 4 root. That is y is equals to sine inverse. sorry, we should just first find out the values of this part. Let me just check if this was, yeah, this is supposed to be in radian. So change your angle unit to radian. Sine inverse 0.25. You get 0. Wait, sine inverse root over 1/4. Yeah, it gets actually pi by 6. The first value is pi by 6. The second value is going to be like 180 minus pi by 6. That's pi minus pi by 6. So you get 4y as pi by 6, and that's 5 by 6, right? Yeah, 5 pi by 6 it becomes, which is certainly outside your range. So we'll just only accept with pi by 6. Then again, you have to divide all these values with 4 again. So you get pi over 24, and then again 5 pi over 24. So the value of your y is pi over 24. But we're not going to accept this because this goes outside your range. And this is the y coordinate of P point P. So for part B, they wanted to find out dx by dy. Okay, so for dx by dy, we need to differentiate that sine square 4y. Okay, so you have for part B, you have x equals to sine square 4y. Okay, so for this question 10b, we're just going to consider this equation as x equals to sine 4y with a whole square, right? In that case, what you get is that you have to apply that chain rule. For dy, so dx by dy, you have, as you have like sine 4y this time, for the chain rule, obviously the 2 will come in front. You have sine 4y with the power of 1, because 2 minus 1 you left out with 1, and sine 4y, if you differentiate that, you get 4 cos 4y, which is basically 4 into 2, you get 8. Then again sine 4y, and lastly cos 4y, right? So yeah, this is the equation for your dx by dy, right? And then if you move on to part C, they want to find out dy by dx, but in this format. Okay, so for dy by dx, obviously I'll have to just flip that dx by dy, which is going to be 1 over 8 sine 4y cos 4y. Now write it exactly in the form that they have provided. You have to assume that your original equation was what? Sine square 4y, right? In that case, sine 4y is actually equivalent to root x, right? And then again, you can consider it like this, that sine 4y whole square plus cos 4y whole square is equals to 1. If sine 4y whole square was value for x, you can write cos 4y whole square plus x equals to 1. Then you have cos 4y, 1 minus x, this square to the right hand side will be root. So now you have expressions for cos 4y, sine 4y. So you can just write 1 over 8. Instead of writing sine y, we can write root x. Instead of writing cos y, we can write 1 minus x under root. So you can just write x, 1 minus x, as both were under root, so I'll just write it under one roof. Now again, they're not only satisfied with this, they want you to write it in terms of numbers. So after this, what we're supposed to do is that you input that 8 into the root over there again. So if you take in that root, take it that 8 inside that root, it will be like 64 inside it, right? So it's 64x, 1 minus x, everything inside a root. You simplify it and you get what? Minus 64x square plus 64x, this thing inside a root. Now again, in the denominator, they have not kept the answer like this. They have actually did completing the square in this part. So for the completing the square rough work, I'll do it on the side. So you have minus 64x square plus 64x plus 0, where a is minus 64, b is 64, c is 0. Now we always keep our answer for completing the square as a x plus b whole square plus c, right? Now the formula for a is just small a, which will be minus 64. formula for capital B is going to be B by 2A. That is going to be 64 over 2 minus 64. That is going to be negative half. And then again for the formula for capital C, it's going to be C minus B square by 4A. C was 0 minus B square was 64 square over 4A was negative 64. So over there you also end up with like 16. And finally, again, if you input these values over there into equation, it will look like they have actually keep the equation as like C minus ax plus b whole square format. This is the equation, or this is the format they have kept their answers in. So I'll just write the answer as the value for your C was 16 minus 64 and then x minus half, right? That will be under a square because this is completing the square format, and everything under a root, right? So this is the final answer. So yeah, from this part we can understand that P is going to be 16, R is going to be like 64 and all, right? If I just go back to your state, yeah, Q is 16, R is minus 64 and S is minus half, right? So you can just write, I forgot again, QRS, okay. So Q is 16, R is minus 64, S is minus half. Right. So yeah, this is it for question C. For part D, we need to find the value of x of the point where the dy by dx is minimum. That means basically this entire denominator should be considered as equals to 0. So we have for D1, like the value of x for which this one is entirely 0, right? So for the value of x, you get what? Like the equation was 1 over 16 minus 64, 1 minus or x minus half whole square under a root, right? So the value of x, we're just going to consider the value of x plus half whole square. So that's going to be like x minus, sorry, for x coordinate, we're only interested with x minus half equals to 0, where x is equals to half. And for the value for dy by dx, we input this value into the equation for your dy by dx, right? So then you get 1 over 16 minus 64. Half minus half is going to be 0, right? So I'll just still write it half minus half whole square, everything under a root. So if you just simply calculate this, you'll consider that this entire thing becomes 0. So you have just 1 over root over 16, which is basically 1 over 4. So yeah, this is the minimum value of this equation. And with this, our entire paper for P3 October 2023 ends.